All right. Let's let this run for a couple minutes before I get started, guys. Today, I was going to do this as a long form video, but you know something? It's too much of a bother. I have so many videos in the works. It's crazy. I have a backlog of like 6+ videos, and that's before the end of this weekend. So if you can imagine, tomorrow's Thursday. Yeah, is it Thursday? Jeez, I don't even know what day it is. It's going that fast. So anyway, yeah, tomorrow's Thursday. So things have been happening pretty quick, guys, and I have so many videos to do. I've got some digital marketing that I'm doing for some companies. Everybody's pretty stoked about that. So we're definitely trying some new things. But today I am going to try and repair this invisible board. So I have this PCB here, and don't worry, when I flip it to a different camera, I will not have that green screen issue. But I've got my overhead camera moved over, and I think we're gonna go ahead and get her started. So I've got some capacitors that I'm going to go ahead and I'm just gonna redo all of them. Why not? And I believe I have some capacitor kits here. Okay, I've got several different capacitor kits. So I've got this guy right here. And the important thing was for me to find some 470 microfarad 25 volt. And believe it or not, that was not the easiest thing. A lot of them wanted to go up to 16 volt, but these ones here, I want to replace them with the exact components. So these are 470 microfarad 25 volt. So I'm going to replace them with like components. And I guess probably the first thing that we should do here, let's go ahead and find the components that I need, I guess. So the cool thing about Amazon is they come in these packs, kind of like this, and you buy them in a whole entire case like this. They're not very expensive. It's like $20 to $30 for an entire case of assortments, and in my mind, that is just a gold mine. Just to keep this, let's say you might never ever have to use it. But if you do, it's going to pay for itself the first time you have to use it. So let's see, these ones here are 470 25 volts. These are the ones right here. And I have plenty of them. Judging from the board, it looks like I also have a 220. So let's see, 470, 680 micro. Okay, so they're all 25 volt caps. There they are. So interesting thing is the replacement electrolytics are smaller than the capacitors that were on the board. Now, given this board is like 30 years old, and it's possible that we have better components nowadays, but it's also possible that they're not necessarily equivalent. So let's see, these ones here are 220 microfarad 25 volt. So I need one of these. I need one. I'm going to replace them all, by the way, every single one of them. So let's see, that's a 470, right? Oh, some of these are really tough to see. Okay, so I got 1, 2, 3, 4, 5, 6 470s. Okay, and I have one 220. And let's see, that one there looks like it's a 100 microfarad. Whoa, I'm gonna make a mess here, guys. Absolute mess. All right. Okay. Wouldn't you know it, one of them that fell is my 100 microfarad. Okay, so I need one of those. And I have some smaller guys here, and I should just go ahead and replace them all while I'm at it. They're all old. So that's a 10 microfarad. And I've got two others that look like they're similar. Are they similar? Can't really read them, guys. So that's a 22 microfarad, a 10 microfarad. Geez, I have quite the collection here. Okay, and I believe they're all, yep, 25 volt. Okay. So let's look for, that's a 16 volt. We can put a 25 volt in there. That's a, geez. I really wish that these were organized like in a fishing tackle box. So here's a 10 microfarad 50 volt. We can use these. So they have a 10 microfarad 16 volt. And there's a little bit of a legend right here on the inside of my kit so I can see what is supposed to be in my case. So here's the 10. Wait, didn't I say I need a... So 25 volt, not this one. Okay. 47, no, 22, maybe. Okay, so here's my 10 microfarad, 25 volts. I need one of those. And, geez. These ones are so close together, they're really difficult to read. I think they're 22 microfarad. Yep, 22 microfarad, 25 volts. Let's see, 22, 47, 33, 220, 22 microfarad, 25 volt. Okay. And I need two of those. And that should have me covered. All right. So the rest of these I'll just kind of clumsily put in the kit. I'll set the kit off to the side just in case I need something else. And what I'm going to do next is power up the soldering station. Let's get her nice and hot. And I also have a desoldering station. Okay. So I got my my Hakko FR410, and the other one is my quick soldering station. And we're just going to go through and remove them all. One of the first things I am going to do definitely is take a photo, for sure. That way there I don't mess up the polarity, and that way there also I know the correct placement just in case. You never know what happens. There we go. Okay. Whew. The smell of that soldering station, it warms my heart and my room, apparently. It's getting warmer in here. All right, let's flip over the cameras. Hold on. Let me check the chat, guys. Sorry, this is something that I should do better. There we go. All right. So I do have a chat open and I can see what's going on. So if you guys have any questions about what I'm doing or why I'm catching stuff on fire, please feel free to reach out to me in the chat. Let's go ahead and switch over to the overhead cam. And let's see. And of course my horse. Hold on. So I have new macros set up so that it will auto open these programs, but it won't happen until next time when I reboot the machine. So I have to have all these programs open in order to be able to control my cameras, switching between all the different ones. And one of the things is being able to switch my zoom on my camera. All right, let's do this. Overhead. There we go. All right, much better. Okay, guys. We are right here. And so one of the things I'm going to do is I'm going to take my marker and I'm going to mark all the old capacitors right off the bat. Because some of them, once you remove them, they might look new and I don't want to get any mixed up. So I'm going to put dots on all of my connections so that you guys can see what I'm doing right there. Okay. So I already cleaned up a lot of these traces. We got a voltage regulator over here. You can tell the ones closest to voltage regulator and obviously the control circuitry for this board are the ones that are popped. So I believe these ones are the problem children. I don't know if you guys can see it a little bit better right there. Yeah, you can see them. Nice and toasty. That one and that one. They're leaking. And they're leaking out the bottom. A couple of them are blown out. This one right here, this one's blown out on the bottom, which is what was leaking all the schmoo down the board. All right, folks. So let's go ahead and let's get this party started. Let's see. Let me make sure that my stuff is all cleaned, ready to go. All right. This Hakko sure does make this a much easier job than doing all this by hand, let me tell you. Okay. So one of the things I can tell is that my suction on this Hakko is not good at the moment. I think I might have some issues. Let me test it out with some of this. Okay. There we go. Just to be sure. This guy just is not cooperating. Okay, so that's another reason, you know, some of the solder is pretty old. I kind of figured that it was going to give me some hard times. So what I'm going to do is make a new amalgam by adding some cleaner solder to it. There we go. And it's clean. That's looking better. I need my board vise. Yeah. Okay. Well, damn the man. I believe I am using too big of a pin on this, so I got to change my my port. Oh no. Oh well, I can do it. Ooh, that's hot. Yes, sir. She's feisty. All right. If I do a bunch of things wrong on this, I am exceedingly tired, guys. I've already recorded like 2 or 3 videos today, and not to mention worked, traveled today. So, oh, come on. There we go. Much better with that smaller tip. These are like tiny little pins that I'm trying to desolder here. That was better. Yeah, the other tip just was not doing it for me. Much, much better. Okay. Okay, much better. Those guys are almost ready to fall out. Fine. All right. Where's my board vise? I'm still assembling my studio here, so I don't have all my parts. Let's try this guy. Hopefully, I don't set the. Hopefully, I don't take this out of focus for the camera. All right. So. Luckily, on this type of card, I can get a pretty good grip with this style of vise. And this is a rubber jaw vise. Much, much better. Okay. So you guys can kind of see where I'm working right here on this section. And that is going to be so much better. Jeez. Here I am fighting the board. All right, let's do this. Woo, those are crusty girls. Okay. Show it. You see the bottom of the cap is completely leaked out. See that? Yeah, she's done. She's done. So one of the cool things about this board is that they did label the polarity. That's kind of cool. And you can see the seat underneath the cap. I've got to clean this now after I remove all those caps. Yeah, that's gonna suck. Tell you what, just for surety's sake, let me get one more photo of the polarity of those caps from a top down, just in case. Is this, are there jobs for slot machine repair? Actually, yeah, one of my followers repairs slot machines, oddly enough. So yeah, there are. You do probably board swaps, and those boards probably go back to the factory. I highly doubt they want you repairing boards individually because there's the chance that you could be hacking them. So you're probably a board swapper, but just saying. Carson, you did not miss very much at all. I am just getting started here, brother. Just getting started. Okay, so I got my Hakko. This is the FR410, an absolute champ for this kind of work. I had to change out the tip because I was using one that was way too large. Just the tip. There we go. Yeah, there's a bunch of goo on the traces too. So they're not coming out as easily as a lot of other electrolytics because it's contaminated. Yuck. That's all right. So let's see. The hard part is keeping this all in frame. Hold on, guys. There. And let me see if I can invert this bad boy. Maybe get you guys a better view of what I'm trying to do. Okay. So from this angle here, I still have access to the back. You guys can see from the top what's going on. So I have a whole bunch of electrolytics on here. I got just a little bit. Oh boy, this one feels really spongy. Like, yeah, it sure is. Okay, come on, come on. There it is, there it is. Oh yeah. Wow. These are all absolutely disgusting. So I will go ahead and clean up all those holes and everything after the fact. We just want to get those guys out of there. Ooh, come on, come on. There we go. Wow, those are crusty. Okay. So the slot machine is right behind me. And before I finish putting this in its case, we're going to go ahead and we're going to pop this board in there and see if it'll power up with the new caps. That'll be kind of cool if it does. Oh, oh shit. Come on. There it is. Just barely hanging on there. Come on, girl. There. Wow. That's crazy that they're all gooey. There, that one came out much better. Still gooey. Wow. You guys should see the legs on those. All right. Let's see. Let's move down to these ones. Right. That one came out much more easily. That's the 220. Now for the little guys. Come on. It wants to come out. Ooh, and these little guys, they heat up so quick. Let's see. Yeah, those are 22 micro. Okay. And this little guy right here. We are. Woohoo! All right, let's see. How many more do I got? I got this little guy way up here. Now I'm gonna have to do some flip-flopping so I can see which ones I want to grab and which ones I don't. Okay, so I got this one and this one remaining, just two. Wow. Hopefully I don't have to fix the traces on that board, because some of these guys are really boogered from the acid in those caps, or the base in the caps. Okay, let's put this guy sideways for these next couple. All right. And the orientation of this guy should be this one. And this one. Nice, that one came out clean. Those ones probably aren't that bad. This is the 100 microfarad. Probably not bad. Oh, let's see, now there's this little booger. It's almost a crapshoot at which one it is. Okay. There we go. I got you. I got you. Yes, this is a 10 microfarad. Okay. Well, next step. Let's double check. I got them all. Good. Let's go ahead and place this guy off to the side. And those guys are nasty. Absolutely disgusting. So, let's go ahead and get a little bit of alcohol. Scrub those traces. See how damaged they really are. Okay. It's cleaned up quite well. I'm going to go in the house, and all my family members are going to think that I'm drinking because I'm going to smell like alcohol. So, you know what they say, guys. If you do the time, you might as well do the crime. So, I hope you guys are having a fantastic week thus far. Let's try some Vikings blood. All right, that'll do. Whew. Damn, that's good. Okay. Back at it. Wow. Those electrolytics really did a job on this. Tell you what, let's see if we can zoom in even further so you can see what I'm doing. I can't read what this chip is, and I don't know if I can see it under the microscope. This guy over here looks like a voltage regulator. This one right here. So what I'm assuming is happening is we are having DC power coming into this board, and probably comes right down here. It probably gets regulated, and then obviously you're going to have your smoothing caps and filter caps. And then once voltage at the appropriate level, then it's going to go out into the circuit. So judging by the flow and the size of the traces, that is exactly what's happening. So you got two different crystals. This one's for the main processor, and this one here is for this guy. Wow. I don't know if these chips are any good, guys. I mean, obviously the plating is wore off on the legs, and it's really tough to see if those legs are still intact because some of them look like they've been eaten away by the electrolytic that was in the capacitors. Okay. It's looking reasonably well. You know, here's another thing. I'm wondering, now some of you guys are probably better at electronics than me. I was naturally assuming that there was DC power going into this board, But I'm starting to look at this, and I'm wondering if this is low voltage AC that comes into this board, because right here you have a transformer, and then right after that is a couple rectifying diodes. So, I wonder if this is where the DC power is made for this particular circuit board, which would make sense why, you know, immediately afterwards you have this chip and this chip. I don't know. Let me know what you guys think. Okay, so I need some paper towels. There we go. Because I'm making an absolute mess of my silicone placemat here. Yeah. And what we're going to do, let's go ahead and put a little bit of flux on the back side. I got to remember that this right here is my field of view. So I'm going to put a little bit of flux on all this in the back and clean it up. I don't use flux like Lewis does. That dude would flood my entire workbench with flux if he could. All right, so let's go ahead and let's try some more solder. Clean up these traces here. Because there is a bunch of corrosion and stuff in there. There we go. Those are cleaned up nicely. So we want to get the old solder off all the components, all the sections of the joints, and that's what I'm doing right now. So, oh, missed one up here. Yeah, that is a lot of electrolytics, guys. Okay. Let's get to the suck. Oh, come on. My gun went into sleep. Wow, it wasn't there that long. Well, I'll tell you what. Let's do this the old-fashioned way then. I still like using old-fashioned solder wick. Okay. I don't care. It just beeped at me because now it's ready. All right, let's get some flux on this bad boy. Okay, let's zoom out. Boop. There you go. Yes. Perfect. Let's just wick these holes clean. Come on. Come on. Bad thing about solder wick is that it's kind of hard not to touch neighboring legs, because there's in such close proximity on here. There we go. Those are beauties. Okay. Ah. Kind of messed that one up. Let's try it again. There we go. I sucked just enough where it couldn't make contact with the port anymore. Got to get it all in one fell swoop, and I pulled it up too soon. There we go. I think I might have to use the solder sucker on that guy. So much easier. God, I love that Hako. Okay. Nice. Ah, gosh darn it, I kind of messed that one up. All right, hold on. Try it again. All right, let's gyrate the board. Get some of these tiny ones. These are the ones that I was really worried about using the solder wick with because they're so close together. Beauty. Nice. Boy, it sure is making short work of this, isn't it? Come on. Let's see. 2 more. Oh, gosh darn it. That was stupid, wasn't it? I thought I had my finger way back here on the plastic, and I didn't. That was dumb. All right. Got my dumb thing out of the way for the day. Okay. Let's see. Just one hole right here that I'd like to check. Beauty. And what I'm doing is I'm holding it up to the light so that I can see, make sure that I've got light through all of my holes. Okay. Okay. All right, it's looking pretty good. Next, let's get the alcohol back out. Let's clean them up. Oh, I don't know if that one is completely opened. And they're not. Okay. So for this, I'm going to use a blow technique. So what I do is I heat the port up, and then I get really close to it, and I just blow, and I just blow it out. Just like this. And it works just beautifully. I know it seems crude, but whatever works, guys. Okay, that is looking really clean. What about my little guys? Oh, those are looking good now. Okay, let's check it for light. Oh, I got a little bit of copper on the front. Okay. Uh-oh. Oh, never mind. I didn't remove that cap. There, you know, sometimes there's like occluded holes that maybe they're part of a revision, but they were not necessary. I had a string of copper, which wasn't for me, because I have yet to even expose copper, but there's a piece of copper wire that was on there. Okay, so some of these traces are clearly worn down on this side a little bit, but the vias are nice and solid on the back. None of them are lifted, thank goodness. All right, I'll tell you what, let's give it a good old bath of the alcohol. Okay. And you can always use a heat gun if you want to speed up this process. I'm luckily sitting right underneath the air conditioner here, and it makes it a wee bit easier for me. It helps dry out these boards, and at the same time it cools me off. Why not? Okay. So most of these look perfectly fine. Okay. So, where should we start? Well, I know what all of these ones are for sure. So we can start with the big ones. It's the 470s at 25. Or, yeah. Yeah, that's the 470s at 25. That's these big guys that I took out. Two, three, four, five, and 6. Not too bad. That's a lot of leaking caps. The problem is that this guy is old. This is like from the 1990s. So yeah. It's hard to say what storage conditions it was under too. Plus, the thing about slot machines is they're left on for years. They're just almost never unplugged. They just leave them running. Have I tried to find a data sheet for the board? So far, not necessary. Yeah, and I agree with Duo Maxwell. It's it's one of those things where I wouldn't expect them to be available. Okay, so luckily on this PCB, they have the polarity marked. So what I'm going to do is I'm going to put them in, and then I'm going to check it with a photo before I go and I solder anything down, just in case, because I have trust issues. All right, just because it's marked, I don't necessarily believe them. So obviously, if you guys have never replaced caps, you can see the white stripe on the side. It is clearly indicating a negative side. And there's also a short leg and a long leg on these capacitors. And you should take note that the long leg, you see that? The long leg is on the positive side of the capacitor. So it goes towards the plus on the PCB. Too easy, right? Yeah. So if there was other traces or something, I do have ultraviolet solder mask, or just mask. And the spot on the PCB where it's exposed and readily available, I would probably normally coat those, but this guy here has a $50 machine, and I don't even know for sure if this is going to work. Not an issue. Not an issue at all. There we go. And last one. And then I'm going to bring the vise back, and we're going to put this bad boy back in the vise. Okay, and there we go. Definitely a size difference on these capacitors. Okay, so we're going to place those as close to the PCB as we can. And also, because this machine might be moving around, what I'll probably do, if this board does work, is I'll come back through with maybe some Celastic, and I will place some Celastic down here near the bases, or hot glue, and that will keep these guys from vibrating and moving around. All right, so next step, let's go ahead and put this guy back in the vise. And I'm going to hold it right there. And what I'm going to do is I'm going to load up the photo. I'm going to load up the photo, and we are going to take a look and make sure that it is exactly how it was in the photo. Okay. So right now, that's what I'm doing is I'm comparing it to this image, and all of the 470s look beautiful. Yep. Good. All right. Now we can just get to soldering. Good stuff. Oop. There we go. Beautiful. If you clean up those traces well enough, it should solder like a dream when you're going to put the new ones back in. If it's not adhering and forming that bond and seeping into the via, then you did not clean the board well enough. So notice I'm heating up the leg of the capacitor and the via, which is the hole. Okay? And together, it'll kind of seep the solder down into the hole, form that bond, and give us exactly what we're looking for. Okay. So let's inspect them. Those are looking pretty good. All right, guys. So right here, this is what I'm looking for. I want to make sure that they form beautiful little Hershey's Kisses, and that the entire trace is going to be covered in solder. Because if it's only on partially one side, that means it is technically a cold solder joint, and you do not have enough penetration down into the via to make a good junction. And now that I have inspected them, I'm going to clip. And notice how I'm holding on to the legs as I'm clipping, because I'm not wearing safety glasses at the moment. I know somebody can criticize me about that if they want. So notice how I'm not bending the legs around too much after they're soldered, because I don't want to be prying up on those vias because you're grabbing onto a lever. So whatever direction they're kind of laying in, that's the direction I want to keep them in. I clip them off right there, and should look beautiful and flush, just like that. Now what I will do at the very end is I have the microscope right here, and I can put it under the microscope and I can look at it and make sure that I've got perfect penetration on the solder, and to also make sure that none of my traces are lifted or broken. But at the moment, it's looking fantastic. So next, let's flip this guy around yet again. Oh, I don't know about you guys, but I do have a problem with getting these things embedded in my arm. So that's why I clean up my soldering area. And that's also why I have this silicone form right here. So if I ever have to wash it, I just take this silicone and I shake it out or wash it. There we go. Nothing worse than getting metal slivers in your arm. Okay, next. Let's see, I have a single 220 microfarad. It's one of these guys right here. And the 220, I believe, was C14, but just to be sure, again, I'm gonna go back on my photos. And it was Charlie 14. Okay. Again, mind the polarity. And let's see, let's get Charlie 7 as well. Charlie 7 should be the 100. Yep, by the 3. That's the 100 microfarad, 25 volt. And also, never trust the bags. Never ever trust bags, especially from like Amazon. Always check. Please just check. Gosh, you never know with some of these items that come from China if you get the correct values. So just because it's in a bag that says 100, just check. Okay, this is about to drive me crazy. I got my soldering cables over here are all kind of mixed up. I've been fighting it this whole time. Okay, next. Perfect. Beauty. All right. Nice. So if you guys are curious on what I'm doing, just go ahead and ask me a question. And I do have a chat that's about a foot away from my face, so I can see what you guys are saying. Leaded solder. Yes, actually. Because I guarantee that this is lead solder to begin with. But yes, I use tin lead 6040. Absolutely. And this gauge right here is my favorite. It's a 2 mil, or no, it's a 1.22 mil. This is my favorite because it's got just enough flux in the core. It works really fine. I don't have to worry about external flux as long as I clean the vias and everything really well. Come on. Again, I hate metal in my arm, so you guys will be seeing me clean up when I clip. Okay, those are all looking fantastical. Next. Okay, so I have a couple smalls up there, and those ones, I have a 10 microfarad and a couple 22s. And holy cow, is that it? Now I'm done? Score. So I think in between the ICs right here is the 10 microfarad. Yes, it is. Okay, and those two there are the 22s. Make sure the polarity's correct. Sweet. Tuned in from my semiconductor job. All right, score. Hell yeah. Let's do it. Shit, most of you guys probably know more about soldering than I do. Okay. Here's that little guy. And, hold on. Gotta pause for a moment. All right, a couple of 22s. And then what I'm gonna do is, for your entertainment, we are going to see if this guy's gonna power up or if it's gonna catch fire. You're gonna find out at the same time I do. So let's do it. Hopefully it powers up and I hear some noises or something, but if it doesn't, then I'll have to do another subsequent video on troubleshooting, because who knows what's wrong. And last one. Wow, it's nice that these are smaller, for sure. Okay, let's double check. Everything's looking good, and these are on solid. Yeah, it's really nice that these are a smaller diameter because it gives me more room to clean and to look and examine. Okay, we're looking good. Let's do it. Woo, my air conditioner right over my head every once in a while spritzes me with moisture. Lovely. Here in Houston, it is humid out today. It's been raining for the last couple days. Come on. There we go. Okay, I'm going to clip that one. Let's see. How does it look? Beautiful. Now, I wish I had my microscope set up because then I could show you guys under the microscope the technique that I use for soldering. maybe a little unconventional, but it works really well. I'm trying not to heat up the PCB very much or very quickly. All right. Holy cow, is that it? Is it really fixed? So, you guys know the next step. Got to give it another bath in alcohol. I'm using 99% isopropyl. Works pretty good at getting the cruddies off these boards. So I'm just going to tilt the board at a slight angle. And let's see, let me go ahead and put the flux away. Get that out of here. That was a lot of caps, wasn't it? Okay. Let's see. Let me get all these capacitors over to the side. Oh, take a break. And do what Maxwell is saying, no flux. There is plenty of flux right here. And believe it or not, if you clean up those vias, like I did, it's not an issue. If I would have removed the old components and then I wanted to put the fresh ones back in, without cleaning the vias so it's nice and fresh and shiny metal, then yes, absolutely you're going to need some flux to get it to flow. It's just, if you clean it, normally you don't need flux, all right? Because there's plenty of flux in the solder, in the rosin core solder. Okay, next. Let's clean all that flux off the back of the board. This is a good time to be checking your solder, because if any of those joints move around while you're scrubbing them, then you have a via that's broken and you probably need to put it under the microscope. It's looking fantastic. I don't know why, guys. Why do I feel like the Bob Ross of fixing electronics? We're going to put some fancy little trees in here. Make little brush strokes. All right. Okay. There, I can see the remnants of the damage right here on these ones, but it is making a good connection. We're going to at least plug this guy in. If it catches fire, it catches fire. Who cares? It was a $50 investment, but we are going to hope for the best and maybe get this guy to power up. So next step, let's go ahead and switch cameras around. We'll pull this guy up nice and close and friendly, so if it does catch on fire, at least you guys will have one hell of a view. And let's see, what else do I need? Let's remove this guy. Okay, we're good. We're good. So there's a plastic case that this card sits in to latch it in firmly. I'm not going to use it. Not right now. So maybe if everything goes well, then I might switch over. But right now, this is just a trial. And what did I do with my cap? This is like ultra pure isopropyl, and if I leave it uncapped, I'm gonna have issues. Like no more isopropyl. All right. Well, while I'm waiting for that board to dry, if you guys have any questions, I would be more than happy to try to answer them. Fire extinguisher. I've got multiple fire extinguishers in this room. There we go. Okay. All right, folks, let's do this. Let me pull the guy up nice and close, and then I will see if we can switch these cameras around. I got to move some stuff in my garage around because I'm still moving back into my studio. It is absolute chaos. But for some weird reason, I love chaos. Keeps you on your toes. Okay. Here we go. What? Is it gonna fit? Yes. There we go. Okay. Let's do it. All right, let's see. We'll put you up there for the moment. All right. Tell you what. Let me move this camera. Hold on, guys. Hold on. The Razer camera just gets such a better image than those Logitechs. All right. Here we go. That looks pretty good right there. Hold on. Of course it's inverted. Why wouldn't it be? Oh, you guys get the point. I don't need to use that camera. All right, let's see. Okay, so this is the slot machine, and it is almost in the exact condition as I found it. This is my $50 wonder. So if it doesn't work, who cares? I mean, it literally came with about $10 worth of quarters inside it. So I'm over it. Down here, hello, down here, folks, down here. There we go. All right, so down here is the slot, and it almost reminds you of like the old ISA slots. I know some of you guys don't know what that is. Old time computers, guys. Really long ass slots. And so what I believe is going on is I'm starting to believe that most of this bus is in AC, and then I think there's little power supplies that are switching over to DC, which is why I kind of had a hesitant moment on this board. And I'm thinking, what if this board really is AC coming in and then it just switches over to DC? Who knows? We'll find out together. All right, so this guy normally has a plastic case and it fits in here beautifully. Come on. Maybe that's why it's got the plastic case. There it goes. Garr. Had to give it a hot supper to get it in there. Okay. And this one here is my relay and switching board. It's got a 50 volt 470 microfarad cap on it, not leaking. So I'm not changing it out in this video, but it definitely showed some signs of heat. But I think this is just a relay board, so you guys can see it right there. I think this guy just activates the AC pass for other things like the coin machine and whatnot. I think this guy is the one that switches them on, and I don't see any rectification on this. Yeah, maybe I do. No, I'm pretty sure that this is an AC switching board. So let's get this guy in. There's a little slot right over here next to this other one. And it's got one cable that plugs in. Okay. So far, that is going way too well. All right, so I got a cable over here, and this one goes to my coin machine. I shouldn't need that to test it out. And I do have an interlock right here, which is this guy. But the cool thing about these old school interlocks is there is a cheat mechanism. There's a hole in the side, so what you do is you depress the interlock, and then you slide something in there, and it locks it sideways. And it's almost like the card bus is in there, right? So that's what I'm gonna do, is depress this guy, shove my interlock cheat in there. Now, when I did photocopiers a long time ago, we used to cheat them with folded paper. I am using heat shrink tube because this is 2024. I don't need no paper. No, I'll tell you what. Can I just cheat it with the screwdriver? Yeah, there we go. Just like that. Why not? Okay. Everything looks good. Power's off. Who's ready to cook some marshmallows? Right? Right? You guys? Good? Yes? No? Okay. My wheels, tell you what. Just because I like the fanciness of these machines, let's go ahead and let's set my wheels in. So here's a cool thing. Now, these wheels have a very large stepper motor in there, and it's got this slot over here to the side, which has got a series of lights. And there's also an indexing on the edge of the wheel. Here's the thing, is it goes from 1 all the way up to 72, I believe. And I don't know if there's a home position that we're supposed to place it in, or if the machine magically knows where it is. I have no idea how it knows where these wheels are. How would it know? Because stepper motors traditionally have the ability to lose steps. So let's see, how many wires do I got coming out of there? I got like 6, 1, 2, 3, 4, 5, 6, 7, 8. Maybe there is some sort of feedback. There has to be, right? I mean, because in other words, how would it know where it's at? But if there is a feedback, it's integral to the motor. I can't see it any place else. And they're very fine stepper motors because of the pitch, you know, the stop. Normal stepper motor is 1.8 degrees. Yeah, this guy's really fine. But anyway, these guys sit back here on a series of lugs. Just like that. It's actually pretty rude. And let's see, here, I'm just gonna take my cheater out. Okay, so these Molex connectors are coming apart a little bit. It kind of sucks, but that happens to all of them because the nylon over time it doesn't do so well. Let's see, that's the first one. Oh, hey, chill. All right. Oh, look at that. I'm still making money. It's still dropping coins. All right. That coin was up inside the wheel here, someplace. Now I'm gonna be shaking my wheels every time I gotta put them in. All right, let's do this. Number 2. So this is really not that complex of a device. It's definitely designed to be serviced and serviced quickly. So very cool. It's got a whole bunch of incandescent lamps. You can see them right here. There's 3 of them. You can see that I have incandescent lamps all around the perimeter. All of them are designed to be quick change. Like you can twist them, they pop right out. Just like that. And I think most of them are good. I'm kind of surprised by that. Yeah. And all these boards come off with plastic inserts, like push pins. There's no fasteners holding those PCBs in. Designed to be maintained. I love it. Okay, and let's see, the third one. I don't know, what are you guys thinking? Think it'll fire up? or not a chance in hell? I don't know, I'm kind of up in the air myself. Kind of up in the air myself. Okay. So all the wheels are lined up, sort of. Uh-oh, hold on. This one here looks like it's bent. What the heck is going on here? Okay. All right, they're not impacting anything. Feels like it's good. All right. Now I'm not going to put the coin machine in because why? It doesn't need to be. Let's see. Oh yeah. Let's get this guy. Cheat it. Okay, folks. I guess let's plug it in and see if I just wasted a lot of time. Okay. All right, we've got power. So, it doesn't have any door interlocks. The only real interlock that it's got is down here. Hold on, let's see. Stepper motors don't actually have encoders at the end. Closed loop steppers do, and servo motors do. Steppers usually don't have any sort of encoders. However, you can figure out where a stepper motor is based on the poles, and they count the pulses, and they can figure out the load on the motor based on current. There's a whole bunch of ways to find out on a stepper motor. Let's see. The wonderful connectors. Oh my God, yes. Those nylon connectors in Steris, they fall apart. I bet money it'll work. Holy cow. That's what I'm talking about. Let's do it. I hope there's another quarter in there. Trust me, I took everything apart on this, including this box down here, because there was quarters everywhere inside this machine. And for all I know, that's why it burned some stuff out. So, ready? Okay, well, I do have some power. However, I don't know if I have any power down here. And I don't think there's a door detect on this guy. Not that I'm aware of. If there is, then I'll be damned. Okay. So I would expect to hear a song or something like that when you boot it up. All right. So I guess we're going to have to do some more troubleshooting. That was too easy. Okay. Did I forget anything? First off, did I plug the relay card in the correct the correct side? Who knows? Okay. Well, I do have a fancy little key here too. Wonder what this guy does. Okay. All right. So it's not doing anything. I did a whole explanation video showing you guys all the components of this and how it works. Okay. Well, for all I know, there could be much bigger damage done. I did take this power supply up here apart. Yeah. So we have AC rails, but I don't know what's going on with the DC. So I've got little power supplies here. Yeah, you can see the interconnect when I take it out. Does its thing. Okay, guys. Well, it ain't got no gas in it. Folks, we're going to have to dig deeper. That's all there is to it. Just is what it is. So I've already taken almost all this apart. I think we're going to have to start chasing down DC. And also on the main board, there is a super capacitor I did not change out. For one, they're not cheap. They're not easy to get. And, well, I guess I should measure my voltage across it to see if it's even got DC. And also, what I should do is get out an oscilloscope and maybe some fine probes. And down here on this control board, we should check to see if we got our DC rails on the chips. Check VCC. And if we have VCC, then we know we should have something powered up. But I do not think that we have VCC. Also, it was extremely suspect. Oh, come on. Hold on. I'm going to unplug it. Let me pull the card out, and I will show you guys up close. Okay. Extremely suspect is going to be right here, what I believe is a voltage regulator. I can't read the numbers on it anymore. And also this guy up here. So I have no idea what these two chips are, but they're obviously due to some sort of power management. Oh shit. You know something? I have a definitely cracked resistor for sure. Well, I'm gonna have to nab a resistor and change that bad boy out. So right here, hold on. We'll use solder. So right here, this resistor right here has got a whole collar section of it missing. And I have no idea what that one feeds off. But these ones right here are clearly the chips that are going to power up the rest of the circuit. No, I'm going to do some more research on this bad boy, and I'll do a follow-up video. And if I can track down what those semiconductors are, which I can, the one, because if you guys remember, I have a semiconductor tester. Hold on, guys. Should we figure out right now? Let's figure out right now. Let's move some stuff around. Let's move this guy around. Let's see if I can get you guys an even reasonable view. Someplace over here, I've got a semiconductor tester. It'll tell me what it is and if it's good or bad. And I don't use it that much, so let's go ahead and do it. Overhead. Whoop. Okay, so in order to use this device correctly, I have to remove this guy right here. So I'm gonna need some little pliers. Let's take that little nut off right there. So this trace down here, there was a whole bunch of corrosion down inside the slot. So I don't even know if the slot is completely good. I cleaned it out with electronics parts cleaners. However, you guys know how well that goes. Sometimes you win, sometimes you lose. There we go. Yes. Okay. And I'm going to desolder this guy right here. Just those three. And while that's heating up, let's go ahead and get my tester out. Let's see. Not this one. There we go. My semiconductor tester. Haha! We can figure out what it is and also if it's good or bad. Hell yeah. Let's do it. So this is the Peak Atlas DCA 55. You can connect these jumpers in any order and you can figure out what a semiconductor is and if it's good or bad. Okay, we good? We good? And let's see. Okay, so it's these three legs right here. Boy, that guy does clean them up quite well. Okay. So it should be free. I'm going to use this little tool right here. Ooh, it's so delicate because those traces are obviously slightly damaged from the years with corrosion on them. All right, let's see. Did we get it? Man, it's a good thing I'm removing that chip too, because there is some goo juice underneath it. Right. Making sure that those legs are completely free. There we go. Why is it always the middle leg? It's like, always the middle leg. So this little bar right here, I'm putting very slight tension on it, just heating it up and getting that to pull free. Like so. Come on. Oh, and there it goes. Probably broke on the fall. And that would be my explanation for it was already broke. All right, where'd it go? Well, apparently that part wasn't that important because it just boogered off. Now I'm not going to be able to sleep tonight because I'll never know if that part was bad. Oh, there it is. Good. There it is. Okay. All right. Okay. So you can see the legs. You can see the corrosion that's kind of on it. Not in a good way. All right, let's go ahead and place this off to the side. So this type of tester right here, just connect these up to any leg, and it tells you what the component is, if it's good, and also it tells you what each leg is. So let's do this together. It says analyzing. It says 3 thermal bicolor LED. That's not a good sign, guys. Pin out for D1. So we got a cathode, anode, forward voltage, test current, pin out for D2. So it's saying it's a double diode. And man, I wish I could read the face. It's just so dirty. Okay, tell you what, let's go ahead and shut it off. I'm going to change these around. It's probably going to give me the exact same readings, just in case. Yep, 3 terminal bicolor LED. Pin out for diode 1, anode cathode. Pin out for diode 2, anode cathode. Okay. So it is testing 2 diodes, so this component probably is absolutely fine. Now the second component, which has got significantly higher damage, this guy I think the legs are still intact, but it's hard to say. I'll have to use a microscope to get in there. And I don't know how you would test this kind of semiconductor right here. No. Okay. Well, shoot. At least now I can get underneath my, what is that? Underneath the component. Let's clear some of this garbage out. Go. Okay. All three of those traces look like they're pretty good. So I'm just cleaning all the schmoo that's off this. Yeah, you can see the corrosion on the back side. Let's put him back in there. So I do not believe that that's the problem. Right. Okay, well, at least we were able to clean it, get it some fresh solder on those pins, and that one's good. Okay. Well, folks, I guess I'm gonna have to end the stream because at the moment I'm exceedingly tired. So what I would like to do is, man, I'll have to examine this guy right here under a microscope. I definitely have to change out that resistor because that resistor looks like it feeds this chip right here. Kind of hard to tell. So, like I said, you win some, you lose some. And so far, I don't think I've lost anything. Just got to dig a little deeper, huh? Okay. A floor type semiconductor. A floor type semiconductor. Can you define what you mean by that? You mean the one that fell on the ground? Yeah. That's right. All right, well, shit. Okay. Well, at least I feel better about the board being cleaned up. Those caps were definitely bad. They were certainly leaking. I also might have to pull that ISA slot, I think it's an ISA slot, and check, because if those pins are corroded, which you can see right here, this pin is corroded. I do have a new type of corrosion inhibitor that I might try, but we'll see. And Dual Maxwell says, try reflowing the legs. You're absolutely right. I'm going to. On a follow-up video. I really can't go any further anyway, since I can visually see that I have a broken resistor. I have capacitors, but all my resistors are at work. Of course they are. So I have to go in tomorrow and I'll snatch them up and bring them back. And see if maybe I can get this guy up and going. Anyway. So, folks, I appreciate every single one of you joining me on this journey. Let's call it a journey. This journey into slot machine mayhem. But I'm going to have to dig a little bit deeper and do some soul searching. And I am definitely not giving up, folks. Ain't no way. I have too much fun with garbage like this to give up. And at $50, it's still extremely low risk, even though I've invested a couple bucks in capacitors. So we'll see. Next time I'm probably going to do some microscope work. So stay tuned, guys. Next time we are going to probably whip out the microscope and maybe a mobile camera so that you guys can see what I'm doing in the cabinet. The power supply, I've already did a video on that, and that one definitely checked out. Although I didn't check the outputs. I checked at the high voltage capacitors on the high voltage rails, and I was good there, but I didn't check the output. So, but I don't have the pinout of the wires, so it's kind of a crapshoot. But anyway, guys, just is what it is, and thank you all for joining me, and we'll see maybe tomorrow or the next day. We'll dig in a little bit deeper, and I don't know, maybe maybe I'll figure out something else to do with this. I don't know. Well, my brain's just spinning because it's a beautiful cabinet. I love it, but there's so many other things I could do with it. This is an old school slot machine. It's definitely an old school one, and you just don't find them like that anymore. So I guess we'll just keep going.